All right. Hi, welcome back after the lunch break to our next session, which is about real-time interactions with large language models. Or dubbed Hello AI. It is a really cool topic. I really like it because it's another topic that shows that AI can be much more than the usual chat box that you know and that you see so often these days. They really make they really have the potential to change the user experience of our apps quite significantly. And so today, I want to show you how to make use of those real-time models. There are actually two providers that are recommendable, I guess. There's also local options that run directly on your own device, and I want to show you how they work under the hood, which options you have, which one to use in which situation, and so on. Before that, we will quickly have a look at the intro. So basically, what is multimodality? What are real-time models? And I want to show you that. Before we start, brief introduction from my side. Christian Liebel is my name. I am a consultant with ThinkTecture, a German-based consulting company. We have various clients from all different fields of business, including medical, financial, industrial, and so on. And basically, we try to help our clients, who are always software developers themselves, to make the best out of new and emerging technology. And of course, AI is one of them. I am also a member of the W3C Web Machine Learning Community Group and Working Group. Basically, the places where AI APIs on the web are standardized. I'm a web developer myself. And I'm also a member of the MVP and GDE programs, the expert programs by Microsoft and Google, respectively. And they basically give us direct access to product groups. So basically, I can call the Gemini team if I want to, or call the Copilot teams at Microsoft and so on, and bring your feedback back to the vendors. So if you have any questions, if you have feedback regarding those products, regarding the specifications, the APIs, then feel free to let me know. We will have a question section at the end. If you have any questions, also feel free to just raise them in the meantime. I try to keep an eye on the chat as well. So dear participants at home, also feel free to just use the chat box. And if it makes sense, I will try to add it directly to our session here. Yeah, my personal focus topics are Angular development. I'm doing this for quite a while now, over 10 years. Then PWAs, progressive web apps, technologies to make your web application run seamlessly integrated with the operating system, run offline, and run performant and fast. And now, more recently, of course, generative AI, locally and in the cloud, and so on. I will upload the slides of this presentation later on to this link. So if you're interested, have a look. And if you want to reach out to me, again, same offer. If you say there's stuff that we need from AI APIs, or if you say it would be cool if Microsoft Edge would support that and that use case, then feel free to reach out. You can also find me on LinkedIn. Just search for my name, and then we can have a discussion. And again, I can only offer to bring your feedback back to standardization bodies and vendors. Okay. Before we actually come to the real-time models, I want to give a brief introduction of where we come from, because this is quite important, I guess. Because that is the landscape of generative AI. Generative AI means that we have an AI model that can generate content that is consumable by humans. This can be text. This is where it all started, right? The ChatGPT moment, when we first saw this chat box where we could type in whatever we wanted, and this AI gave us something more or less reasonable back. And the next evolution step was images, I guess. We all may still remember DALL-E. That was one of the first larger image generation models. We've seen many interesting creations on social media, at least I did, sometimes dubbed AI slop because it was so bad at the beginning. It has significantly improved since then. It's actually quite useful, and at least I see more and more people actually making use of it, and the production quality is pretty good nowadays. Right now, a big trend that we see is Sora. And again, at least my social media feed is full with Sora-generated videos. Some of them, yeah, are quite funny, right? So some of them are not really meant seriously. So just before the session, I saw a cake in the shape of a cat, right? And it looks realistic. And there's a cat right next to it, and basically a woman wants to cut the cake, which looks like a cat, and then the actual real cat was shocked by the woman trying to cut the fake cat. Yeah, that is basically a funny use of AI, but maybe we've also followed other video models like Veo. That's a video model by Google where they create like cinema class videos just from a natural language prompt. And this is very interesting because it gives all of us the ability to produce Hollywood class movies in the future, which is quite interesting and can also lead to interesting results. Apart from that, there's also like audio and music generation. There was a famous German song in the charts last year generated by AI, so the text and the melody and the singer, right? So the the voice, so to say. And yeah, also more recently, speech-based APIs, so basically where you can process speech spoken by humans and also generate speech. I mean, that's a little bit older, that field already. This is not like super new, but yeah, has been around for a little bit longer. Today, we will focus on two things. We will focus on text processing and on speech processing and how you can bring this together to implement very interesting, very compelling new use cases for applications. And these are typically dubbed real-time models, and we will have a look at that. All right. Now again, really brief demo. I don't want to bore you. We will definitely talk about real-time models in a second. We just have a look at where we come from. This one was where it all started. Large language models like the GPT model, where basically you sent text over to the model and it responded also in text. Nothing new, nothing special, nothing really surprising anymore, right? So here, let's have a quick demo, and all of you will be terribly bored because that's so normal now. So let's go to also maybe interesting, if you want to use an AI model without having to sign in, then Microsoft Copilot is actually quite a nice deal because you can simply use it without login, including the real-time models, which is pretty cool. I tend to use this really often because also I don't want to share my ChatGPT history now, right? And basically you can use this. It includes, by the way, the real-time agent, so you can also talk to it without any login, which is quite nice. And then, of course, you can ask questions, right? So what is the capital of Bavaria? Hint, it's the city that we currently are. It is Munich. Awesome, perfect. And now we get this like bunch of text. Yeah? And this was where it all started. That was the ChatGPT moment. People started to realize, okay, that is what we can do with generative AI. That's very impressive, very awesome. And in the meantime, absolutely commodity. So I see this on the train. People are using it. Non-techies, right, are using it randomly. In meetings, somebody says, "Oh, I will check that back with ChatGPT." When you think, "Oh no, please don't do it," yeah. But people just do that now. It has become standard, actually. I just visited a conference last week. It was a domain conference in the public sector, and every second booth had a chatbot. Right? It's so commodity now that everyone knows that exists. And many people use it. But nothing to stand out anymore. It's commodity, it's normal. All right, then, next evolution step, multimodal models. We don't only have text, but we mix it also with various other formats. For example, images. We can send a natural language prompt in text and we get an image back. Or we I don't know, we send an image and get a textual description of it, right? So what is in this image? Great for accessibility, by the way, on the web. If your system can automatically detect what an image shows, so you don't necessarily have to enter an alt tag anymore, although it's nice to do that, right? An alt attribute, continue to do this, but basically this also improves accessibility. And then you can request videos now, or just send an image and generate a video for it, and so on and so forth. So many things that you can do here. And here's a small demo that we can also have a look at this. This is Adobe Firefly, and it allows us to generate an image from a natural language text input. Wait. Here I have to log in again. So basically I have to use the non-incognito mode. Yeah. And here now we can describe what we want to generate. Interesting. Adobe doesn't suggest its own model. Also could tell us something. So we will use the Firefly image 5. And we can generate an image. Does somebody have a prompt that we could use? So I'm totally uncreative today. Okay, just an idea, just a random word that pops up in your mind. Okay, sorry, no, I didn't hear you both. What was yours? Munich conference and? A cat cake, okay. At a conference in Munich. Okay, let's see what happens, right? So this is like very specific. Yeah, Adobe Firefly is very nice. You can basically choose different kinds of formats. You can also upload a reference image. So if that image should look somewhat similar to another one, you could upload this. You can pick the, oh, that is nice. You can pick the style, if it should be a sketch or something else, a drawing maybe, a painting. All right, and this is a cat cake at a conference in Munich. This is like not good, to be honest. Let's maybe try it with another model. Let's see what the older one does. Yeah, and here, this is what I said, here you could choose the content type, or for example, pick a certain art style. Okay, yeah, nice cat cake, still not photorealistic, still not really in Munich, but well, again, it is like also super specific. Yeah, and these are multimodal models, text in, image out. And also, like, not so super new. So in Photoshop for several years now, 2 years, 3 years maybe. So again, nothing really surprising anymore. Yeah, and then this started to happen. Real-time models showed up. And they are in fact different. And we will later on see how they are also architecturally different from the other models that we typically use. Because here the models respond in real time. So we send text to them and they can send, speech to them and they can send text back or answer with speech. Or we can send an image to them and they respond with speech or whatever, right? So it's really, you can mix and match it as you need it. And the first demo that I want to show you is a custom demo. So we will also have a look at the vendor demos later, but I want to show you one demo that I built. So also for those who joined the workshop yesterday will be familiar with that. This is an insurance form, and instead of me entering the info manually, right, with the keyboard, I just use my voice to fill in that form and to navigate inside the application. And we will use a multimodal model to detect where the damage has happened, because this is basically a car insurance, car crash form. And I will show you how to control this with voice. So let's have a look. So here is our demo. It's already started. Perfect. All right, now let me see. Yes. So I will do it from the speakers here, and I hope you can hear it. Let's see. All right. Hi, good morning.
Good morning. How can I brighten your day today?
I would like to fill in this form, please.
Absolutely. Let's get that form all filled out. What details would you like to start with?
Okay, my first name is Chris. and my last name is Liebel. And I live in Leimersheim in Untere Hauptstraße 3. Perfect. What else is missing?
We're making great progress. We still need your insurance ID, date of birth, telephone number, email, and license plate. What would you like to tackle next?
Oof, I would like to go to the site vehicle damage. Okay, so also basically navigations are possible back and forth between different pages. This one shows another multimodal demo. This one detects where a car crash has happened, right? So normally in this insurer's case, you would have to click where the damage has happened. Here, we use AI to detect this. We can simply search for an image of a car crash. Yesterday we had one in the workshop. Let's use a different one now. Yeah, well, I don't like them too much. Let's use that one again. So, I mean, we can all agree that the damage here is at the front. So let me save that. Go back. And use this exact image. And now we use this multimodal capability to let the model detect where the car crash or where the effects were, right? And so now this tells us that there was like total damage in the front, which I think is true, maybe scratches and bumps at the side, at the top, and so on. And this was all detected by the AI. Now, the cool thing is you can also, of course, switch between languages. Let's do this. Gehe zurück auf die Seite persönliche Daten. Was muss ich sonst noch ausfüllen?
Wir brauchen noch Ihre Versicherungsnummer, Geburtsdatum, Telefonnummer, E-Mail-Adresse und das Kennzeichen. Was möchten Sie als nächstes hinzufügen?
Okay, and then basically, right, so this game goes on and on and on, and you can navigate back and forth, ask questions, where do I find this insurance number, right? You can feed in your domain knowledge that you have, because this insurance number will be somewhere, right, in, I don't know, on your, how's it called, on your confirmation sheet, so to say, of the insurance and so on. And you can all add this here, yeah, and make a very nice, or create a very nice user experience out of it. That's the idea. These are real-time models. You can talk to them. And the foundation is, yeah, is models that we already know from providers like Gemini and from providers like OpenAI. And we will get to know them as a part of this presentation. Okay, so real-time models. The cool thing about them is that they process speech input and output natively. That means they understand voice directly. There's no transcription needed. We directly use waveform input, so to say, as input for the AI model. And that way, it does not only understand basically the content that I speak, right? So the content of my speech, but it also understands the voice itself. In which emotional situation am I? Am I stressed? Car crash, yeah? Am I sad? Am I happy? And so on. This can all be detected by this model and processed by that model. Transcription is optional. You can turn it on if you like, but it's not the primary data point, so to say, that is being used for processing. Multiple languages and output voices are supported. So basically, you can also switch between languages, as I've shown you during this demo, and you can choose which voice you would have to speak the responses. You can choose from various speakers, so to say. Tool and function calling is supported, so this means that you can extend those models by your own application-specific actions. In my case, in the demo that I just shown you, it's filling in the form, that's a tool, and navigating between sites, that's a second tool. And detecting the car crash location is another tool. And so they are all supported. And that way you can extend the possibilities of the model. Voice activity detection is activated automatically. That means that the model will automatically determine when it's time to respond. You can also interrupt the model. I'm not sure if I showed that now in the demo. We can have a look at that later. So basically, it automatically stops when I interrupt it. Right, so that's this point. Oops, sorry. And that's basically the basic characteristics of real-time models. Which use cases are possible? First of all, natural language interfaces. So you can, for example, just directly talk to a model and ask questions. I did this recently when I drove back home from the train station to my home, and I needed to get something done. Right? I needed to write a text, and it's of course hard to do that when you are driving a car. So basically, I just used the Copilot app again, right? Press the speech button, and then we just formulated my email together. And then when I was back home, I could just copy the email and paste it into my email program. So that is really helpful. Smart form filling. This is what we just did. I can talk to a form, can ask questions, and can have the form fill itself out automatically. Navigation between various parts of the application, voice assistants like a Siri that is actually good, phone agents. That is a use case that I've seen on this public sector conference last week. They essentially use a real-time model. This is like an administration of a smaller city, and they just attached a real-time model to their hotline. And so basically, in order to reduce the load on the public service people, we would have to answer all of those questions. They just have a real-time model answer those questions. And they added tools so that you can ask stuff like, who's responsible for cleaning the basically the street, right, where I live. And then basically the AI model can look it up. Or when is the paper waste being fetched and stuff. This can all be answered by a phone agent, so you don't have to, so you can reduce the load on the actual people that work there. Also, you can use that as additional or alternative input methods for accessibility. That is something that one of the conference participants told me that this is very useful for ticket machines. Because if you, for example, cannot see, so if you're blind and you don't know where to tap at on the screen, using speech is a pretty good alternative to navigate through a ticket purchasing process, for example. And so that's all possible use cases for real-time models, and I'm sure this list is longer, and I'm sure you have already a use case in mind for the application that you build. There are two main models that currently come into question, at least from my perspective. There may be more, but that's the two that I worked with. There's the OpenAI Real-Time API, and they offer two real-time models. One is GPT Real-Time, the other one is GPT Mini Real-Time. It's a little bit cheaper than the other, but of course less powerful. And from Google, there's the Gemini Live API, and they have two different models. One is a half cascade model, which is better suited for tools, and that's Gemini Live 2.5 Flash and Gemini 2.0 Flash Live 001. The model naming is awesome. And the second category is a native audio dialogue model, Gemini 2.5 Flash, which supports reasoning capabilities, but is less suited for tools. Let's compare them a bit. So what is offering what? There is indeed some interesting differences between the two. OpenAI Real-Time API supports more than 57 languages. It supports speech and text input and supports speech and text output. Actually, I'm sorry, I just had a look at the slides before this talk, but I missed that. They also support images now, so that has been added in the meantime. OpenAI Real-Time API supports WebRTC and WebSockets, so two ways of connecting to the real-time model. It does not have a JavaScript SDK yet, so you have to write the code yourself. I will show you the code later on, but it's not hard. It's like 50 lines of code of JavaScript, so it's pretty easy to do. All right. Gemini Live is a little bit different. They support 40 plus languages. They support speech, text, and video input. That's interesting because you can also basically use a video feed as an input. Then the model has an understanding of what is happening inside that video feed, and it supports speech and text output. However, they only support WebSockets, and that's a little bit more inconvenient to talk to. Also, in that case, there's no JavaScript SDK yet, and the integration is heavy though. So it's 1,300 lines of code. Basically, you have to copy and paste the code from their GitHub repository. Not so super convenient, but once you have properly set it up, it's comparable actually to OpenAI real-time API. So the model behavior is not that much different. Okay, let's talk about the WebRTC, because also for the rest of this presentation, I will refer to the OpenAI real-time API and WebRTC because it's much easier to integrate, at least right now. That may change, of course, in the future. And it has native WebRTC support, which makes sense because WebRTC stands for Web Real-Time Communication, and that's exactly what we want to do, right? And so this API was originally built for real-time audio and video communication. Think Microsoft Teams, Skype, Google Meet, and so on. And you all use that, I guess, maybe on a weekly basis, maybe even daily. Then you are using WebRTC if you use one of those online services. Apart from sending video and audio over the wire, it can also be used to transfer data. If you have chats, for example, then this is sent over the data channel of WebRTC. Yeah, as I said, used by many meeting tools, and this one is a web standard. So W3C knows so-called recommendations. These are formal web standards where the organization has, or the member organizations have voted and have said this is a good idea. We want to have this on the web. So WebRTC is an official web standard, supported for several years now by various major browsers. Chrome 27, Edge 15, Safari 11, Firefox 22. So yeah, quite an old API actually already. Definitely a baseline API, as we call them. Yeah, if you want to learn more about it, here's the link. Typically, you wouldn't integrate that yourself. You would have a library that manages WebRTC in between. But in that case, we will actually directly connect using WebRTC. And I will show you that in a bit. What we also need is the so-called GetUserMedia API. It's actually a companion API to WebRTC, which was implemented before WebRTC. And the Media Capture and Streams API gives you access to the webcam or to the microphone of your PC, of your device that you use, and allows us to get access to that via JavaScript for audio and video input. And this one is a candidate recommendation. So not yet a formal web standard, but basically a effectively it is one, right? But it doesn't have the status yet. Especially if you have a look at the browser support, also this is a baseline feature, so supported by Chrome 21, Edge 12, Safari 11, Firefox 17, so for a longer time already. So this can also be considered a baseline API and available on virtually any user agent that people use right now. Okay. Let's have a look. We will see the two APIs now, WebRTC and GetUserMedia, Media Capture and Streams API, when we try to connect to the OpenAI real-time API. First step is we need to open a new WebRTC connection. In JavaScript, this is called RTC peer connection, and then I use this in a variable called PC for peer connection. Okay, next, I need a setup for playing audio. In order to hear the AI assistant answering, I need a way to play that audio on the web. This is the audio element introduced with HTML5. And so basically we're enabling this, set autoplay to true, and set the source object to the output track of our WebRTC element. And then now we have the output feed, and now we need to feed in audio. And therefore, we need the media capture and streams API, get user media. In that case, we only request audio. So if you were Microsoft Teams or Google Meet, you would also request video. And then we will add that input track to the peer connection as well. Now we can talk to WebRTC, and we can hear what somebody else is saying from WebRTC. Okay, now I told about the data channel. So we also want to transfer data basically separately from the audio and video tracks. And therefore, we create a new data channel. Here we call it OAI events for OpenAI events that are sent back and forth. And here in this very basic case, we just pretend we are logging into the console. And then that's the setup for sending the data basically during the session. And now we need to connect the WebRTC session to the OpenAI API. This is the last step, number 3. And therefore, we need to specify the OpenAI URL, which is this one here. We need to specify the model, GPT real-time, GPT mini real-time. Then we need to, that's basically WebRTC internals now, SDP, I think it's session, the description protocol or something like this. That's already WebRTC details, not super interesting actually for us. It's just needed. And then basically we send the authentication info to it. And basically what we get back is the session description, which we then need to attach to WebRTC. And essentially that's it. Then we can talk to the AI model provided by OpenAI. So actually pretty straightforward. Yeah. Good question. Question is, can we add system message context to it? Yes, you can. So that's perfectly possible. I will show you how. Okay, so let's have a look at one of the demo applications by OpenAI. That is this one here, the OpenAI real-time console, because it shows also the messages that go back and forth. And it has a little demo built in. It has a tool, the color palette tool. You can ask it to create color palettes for us, right? So if you need inspiration for your color theme or color scheme of your app, you can ask this thingy. All right. I need to go to my terminal here, stop that, it's the next demo, and start this. Okay. And now we should go to localhost 3000, and this is now the real-time console. So let's make that full screen. We start the session. Okay, hi.
Hey there, great to hear from you. How's it going?
It's going fine, I guess. How are you?
I'm doing fantastic. Thanks for asking. I'm here ready to dive into whatever you want to chat about. What's on your mind today?
Okay, what you can also do is essentially send in the messages via text, right? So there's the send a text message box at the bottom, so you can do the same thing.
I totally get that. It's like having that familiar text box, but now you can just talk it out loud. Super convenient, right? You can ask me anything, just like you would in a text. What do you feel like doing or exploring right now? Ooh, great question. I actually love a vibrant turquoise, something bright, lively, and a little bit calming at the same time. But hey, I love all colors. Depends on the mood.
Yeah, well, okay. I need a color palette, and I love red. Can you generate me one?
I've got a color palette ready for you, full of vibrant reds. Do you like the look and feel of these colors?
Ich finde es ganz, ganz, ganz schön. Ich brauche eine weitere Farbpalette, und zwar zum Thema Nebel am Morgen.
Hier ist eine Farbpalette zum Thema Nebel am Morgen. Gefallen dir diese Farbtöne?
Oh, they are excellent. They are so grayish. Now we need another color palette, please. That reminds me of grass and nature.
Here's a color palette inspired by grass and nature.
Okay, and basically that's the way that works, okay? So we have this audio session going back and forth, and here you can see basically all of the different calls that go back and forth. Maybe we can even find, here we can see the transcript, again that's optional, what the what the assistant said. Maybe we can find the tool call also. Let me see. Conversation item added. No. Yeah, here. This one is the tool call. So in that case, the model, I said something like, give me a color palette that resembles grass in nature, right? And then we have a JSON schema that defines the setup or the object shape that the model should call. And it does that exactly here. It knows that there is this display color palette tool, and now it invokes this tool and sends in various colors, right? These are determined by the AI model, and this is basically the API to hand over the color palette here in the tool. So this was invoked by the API itself. And it has basically deemed it necessary to call this tool by what I said, right? So I said, give me a color palette, and this basically leads this model to call this tool here. We will see it in more detail shortly. Okay, this is the OpenAI console. Yeah, what happened in the meantime, or when we just had a look at this demo, is the following. On the left-hand side, you can see the input audio buffer. That's basically the speech. And then what the AI model, not really the model, what the OpenAI API creates for us is exactly the conversation in the middle. So it does this voice activity detection handling for us, and it knows when I spoke something, when the assistant spoke something. And important is like this wave form displayed to see there, because it's all about speech. Remember, the transcription is optional. That's not the input, or not the direct input. And then basically we get responses back. That's how this is set up. Also, at the bottom you can even see, it's also quite nice, where exactly the assistant is in the response, so you can even figure out that. So where exactly it is when basically producing the response. That's how the session works. Let's have a look at the session events. So when we set up, so when we basically connect to the OpenAI API, we first get this event. So this event comes from the server to us. It says session created, because by default, a default session is open for us with default values, so that it can start right away. In the code you have seen that I didn't have to set like a voice, right, or the behavior or the system message. So basically they just determine default values so that you are good to go. You can update it though. So if you want to do stuff like change the system prompt, then you can send a session.update event over to the API and set up the modalities. I want to do image, voice and text and images, right? You can set up the tools. Here's the display the color palette tool. Here's fill in my form. Here is whatever, right? Navigate inside the app. You can turn off the turn detection also. If you want that to do, you can specify the voice and so on, all possible during session update. And once the session was updated, you will get an event back from the API that says it was successful, hopefully, if you set the correct values. All right, let's have a look at that session.update doc entry. And this will exactly show you the system prompt that you can set. Okay, seems the direct link has not worked, so here we are, session update. Okay, and here you can, for example, define the tools, and here in instructions, this is exactly the system prompt, right? And here in that case, they said, you are a creative assistant that helps with design tasks. Perfect. Write the tools, and more things here, like the voice, which one you would like to use, the model that you want to use, turn on, off, turn detections, and so on. That's all possible from this event, so to say, right? So here's the full config. You can see there's more that you can do. So it is quite elaborate. Okay. That is the session event that you can set. Next, I want to show you some input audio buffer events, what happens while we are speaking. And one of them is input audio buffer speech started. In that case, the API has detected that I started speaking. Maybe you've seen that. We had this little animation in our demo app that basically visualizes the voice, right? And this relies on those events. So in that case, we know that we are now talking. Speech stop means that we have stopped talking, and input audio buffer.committed is basically is sent when the API has created that conversation item, right? So when I stopped speaking, it creates the conversation item and adds that to the conversation as we've seen before. Okay, and some more events that happen. If we want to create a conversation item programmatically, we did that when I typed in whatever. I don't know what I typed, basically in the text box, right? Then we can also send from our side conversation item create to programmatically create a conversation item. And it's not only for text input, but also when your app has noticed something, right? So when there was an action in your app that happened and you want the model to respond, you can use the exact same mechanism. And when it was created, basically we get back the confirmation that it has been committed. Yeah, and then basically we get to know that. This has effects on our application architecture, because if you usually do AI stuff, then it looks, in most cases, like this. There's a request and response setup, right? So we ask ChatGPT, please, what is the capital of Bavaria? We wait, or maybe we also have streaming, so we see the tokens coming in, and then basically it's done. Answer is generated, capital city is Munich, and that's it. It looks different for the real-time models though, because in that case there is no real end. So there is an end when I close the tab or when I end the conversation, but apart from that, stuff can happen over the entire lifetime of the application, and so that is no longer request response, but publish subscribe. And that is important to bear in mind if you build APIs around that. If you want to build an abstract API for both cases, you will have to build it in a publish subscribe way, because request response is not enough for real-time models. Just a tip from implementation experience, because I had a hard time doing that. Going back to PubSub. All right, that's cool and all, but basically now we want to change the world, and of course the way for AI models to change the world is MCP servers and tool and function calling, right? So connecting the AI model to real-world services, and so we can use tool and function calling to do exactly that. For example, to extend the model's knowledge by, let's say, accessing custom data. So that could be your, let's say, customer data, articles from the internal knowledge database, connecting it to your order system maybe, to Wikipedia, to a postcode API, which I did, by the way, for the first demo. This is all possible because, or let us do a web search, right? And that all extends the capabilities of the model, because now the limits are endless, so to say. You can feed in whatever you like. You can have it do whatever you like. And you can extend the model's capabilities also by executing real-world actions. So now the AI can do something in the real world, right? So for example, navigation, change the page that is currently open. It can send an SMS, update an order status in the database, change a file, fill in a form, perform a web search, and so on and so forth. That can be done also with the help of tools. And if you've heard of agentic AI and React and so on, it all comes back to MCP currently, an agentic protocol invented by Anthropic, but currently the de facto standard for agentic workflows. Now suddenly you can connect your real-time model to whatever service you want, to GitHub, to Playwright, or connect to a browser, to the file system that you operate on, GitLab, Slack, Postgres, whatever. This list is, of course, also not exhaustive. There's many, many more. Microsoft is currently building MCP servers for everything that they have in their product portfolio. And so basically, these are all potential targets to be controlled by AI agents, and basically, in the end, also by your voice. Imagine a world where you don't have to type in stuff anymore, but you really just sit in your armchair, right, and you just tell the AI model what to do. Open an Excel sheet, give me the numbers for the last financial year, multiply them by 3, make a new Excel sheet, add the numbers, generate a chart, and so on. That's all possible to do. Okay, back to OpenAI Real-Time API. We can add tools there as well. We've seen it twice now in 2 demos. You can do it at 2 points. First one is at response level. So basically for a specific ping pong, so to say, request and response, you can set it, or on session level, if it should be available during the entire time of the conversation. You could also imagine like a scenario where some tools are only available during a specific time frame. Let's say in a banking app, right? I have the overview of my transactions. Now I say, please go to that transaction, and only now I have the possibility to send money back, right? To get details of that transaction. But as soon as I leave the transaction screen, all of that stuff doesn't make sense anymore. So I could only add the tools during during I am on the transactions details, for example. Yeah, and when it then processes input, the model determines if it should call one of those functions that are present or tools. That works good in most cases. You can also define a natural language description. That's very critical for the success of this principle. Because if I, for example, in that color demo, sometimes when I just ask it for what are nice colors, or tell me some nice colors, it says stuff like, what was it? Turquoise, right? Yeah. But it doesn't call the color palette tool, because it is instructed to only call that tool when it wants to display a color palette, right? So in that case, it's you have to make the description as precise or as loose as you need it, or as what you expect basically from how the model should behave. The function is not being executed by the AI agent, but must be executed by you, so by the client. That is the web application itself or a server component that is in between. And once the function has been executed, we, so the client, have to send back the result of this operation to the AI model, in case we want to send it back. If it's like a fire and forget tool, you don't have to do this. But you can also send the result back to the AI model. Okay, here's basically the workflow for tool calls. Here we have session update, right? So basically we have created a session, we want to update it right away, and we say, hey, here's the new set of available functions. In response done, so basically I set something, the AI responds and wants to call the tool. It sends us response done with the function call that should be executed. We've seen this before in the color theme demo. And then using conversation item create, we can send back the result of the function call if we want to do so. And this brings us to another demo that also supports tool calling. This is a solar system demo that you can control by speech. It shows the solar system in a nice 3D animation, and basically it can move the plants around and stuff, and it can all be controlled by using speech. Here, we can see that in the description. For example, we can ask to focus on a specific planet. If we ask for moons, the moons will appear. If we ask about data, then they will show data for that particular planet, and so on. So let's have a look. That was here. We need to stop this, start this. And it's still localhost 3000, but this time with a nice and cool, it takes a while to load. Yeah, perfect. Solar system. Okay, so let's see. Please go to Mars. Show details for Mars.
Mars is the fourth planet from the Sun. It's often called the red planet because of its reddish appearance due to iron oxide on its surface. It has a thin atmosphere and surface features both like the moon's craters and Earth's valleys.
Okay, thanks. That's enough. Okay, let's see what else we can do. I don't really know it. Okay, it was data, so it's...
No worries at all. We can look at the orbits of the planets, compare different properties like their sizes or distances from the sun, or explore moons. Just let me know what you're curious about, and I can show you more data or visuals.
Okay, can we explore Pluto's moons? Okay, interesting. So that's OpenAI's demo, not mine. Yeah, and that's basically another demonstration that does not need chat boxes, right? But changes the experience. This could be great for a museum, for example, where you have voice as potential input method for for navigating around the solar system. Okay. Here in the demo, we could add the possibility to we could have a look at the tool setup, so a new window. And here, basically, we can see the different tools that are supported. So here there's like focus planet, display data, show the moons, get ISS position. Okay, that's also possible. Reset the camera, show orbit, and so on. And you can basically define as many tool calls as you wish. And now we should also be able to find the configuration. So here, for example, are the instructions. That's the system prompt, right, for this specific demo. And here you can define the various tools for the model, right, in the shape that it needs. We can try that out now. We can, for example, say show my location, and description is shows the user's location in the solar system. Okay, perfect. And basically to implement this, we need to find the scene again. We say case show location, and then we say trigger animation. I think it's Earth, but we will look that up. And then basically break. And that should be it. Okay, let's have a look at planet. Enum is planets, and what planets do we have? Sorry, come on, go there. Okay, so Earth, uppercase E. All right, and now let's build this again. And start it again, and now we can ask it to show us our location, and then should move to Earth. After building. Start. Okay. Please show me my location in the solar system. Test, test.
I can hear you loud and clear.
Okay, can you show me my position in the solar system? Oh, okay, maybe it failed. Let me see if we see an error. No, we don't. I hope the building worked. Let me see. So for that case, I have prepared a branch, but I think I did what was needed. Let me see. We did this, yeah.
No worries.
We did this. It's actually fine. Okay, well, whatever. Maybe I didn't build it properly. Maybe I have to reload without... Oh, that could be an issue. Ah, well, because I stopped the thing. Okay, let's try it again. Maybe I messed up. Otherwise, that's the way it would work normally. Show me my position in the solar system. Ah, okay. Whatever. Maybe I missed something, but that's usually the way you would do it. Sorry that that didn't work. Happens sometimes. Okay, let's talk about pricing. So how much does it cost? Here are the pricing options. So for GPT real-time, you have to pay $32 for 1 million input tokens. Perfect. Question is answered, right? So what does it mean? What is a token? Here is, so basically, I don't know, I don't have experience with it. Here we, this is a forum post from like approximately a year ago, and they said per conversation it's approximately $1 per minute. So it's relatively expensive, but think about what a human person basically could cost for answering questions and so on. So that would have to be weighed against it. And also, I'm not sure if it's still the case, especially if it's like if it was for real time or the mini real time model. So it may vary, and you should have a look at that yourself and just validate how much it is. Okay, if you follow me personally, then I also like to do the local stuff, right? So progressive web apps where you can install apps to your system and where you can just basically go offline and everything just continues to work. Is it also possible for real-time models? The answer is yes and no. It is possible. Let's have a look at it, and we will also see where this concept fails. So here, let me start the conversational web GPU demo. Basically, same principle. Now we have Heart.
Hey there, my name is Hart. How can I help you today?
Oh, wait a sec. We turn off Wi-Fi, right? We're offline now. Let's do it again.
Hey there, my name is Hart. How can I help you today?
Hi, Heart. Can you please tell me the capital of Bavaria?
Sure thing. The capital of France is Paris.
Okay, but I meant the capital of Bavaria.
Oh, I see. The capital of France is Paris. But if you're referring to a barrier, I think you might be thinking of the Great Wall of China. It's the longest wall in the world.
Okay, and I guess you can already see the problem, right? The thing is, you can have real-time conversations, but the quality is, at least right now, pretty bad. What they do here is actually quite impressive, because that's not a real-time model. Instead, we see 4 models at once. We have Whisper, an open weights model provided by OpenAI that does the speech-to-text translation. And basically, my voice is converted to text. We use Silero, I don't know, for voice activity detection to pause, to be able to interrupt also the other agent. And now, and that's the core, the text that has been transcribed from my voice is being fed into small LM2, a very tiny model with only 1.7 billion parameters. So that is barely usable and barely knows that, yeah. In that case, it didn't understand Bavaria, could also be Whisper. We would have to investigate this now, but basically don't expect wonders by a small model such as small LM2. And then in the end, we use the output of that LLM and use Kokoro, a text-to-speech model, to produce the spoken text. And it's actually quite impressive that that works, right? So it uses streaming all the way. And while I'm speaking, it transcribes my speech, feeds it into the language model, and while the language model responds, we convert it to speech again and play it. It's actually surprising that it works, even though the response quality can't be as good, naturally, due to the model choice here. Okay, but it's also possible, and let's see what the future will bring. Local large language models get better and get bigger and so on, so maybe this changes one day. So, summary. Real-time models unlock new and exciting opportunities for natural language interfaces beyond the chat box. And that's important if you want to impress people, no chat boxes. It's bidirectional, multilingual, and has minimum latency, as we have seen. Yeah, that's not really true anymore, actually. So basically, as well, so OpenAI and Gemini Live, they are no longer in beta or preview. It's also something I missed on that slide. I'm sorry. They are both generally available now. Quality is good but not perfect. Maybe we've also seen this, like the turquoise answer where I didn't do the call. Yeah, and it's pretty exciting, I guess. Pricing seems quite high, but again, it has to be weighed against alternatives, and especially, it's fun. So maybe if you are on your way back from the conference or in the hotel room this night, then just open the Copilot app by Microsoft, for example, no login. You can directly press the real-time button, and you can have a nice conversation with an AI agent. Great in the cases where nobody else is around you. Yeah, and it's no science fiction, so make sure to try it today. With that, I want to thank you for your kind attention. Thanks for joining. Do we have questions? Yes.
You said that the AI models can detect basically your mood
Mm-hmm.
by the way you're speaking. Can they also act on it? Like if you were to invoke, let's say, a function if the user is angry or sounds angry?
Okay, question is, can we respond to the emotional state of the user? Because the model can detect this. I haven't tried that out yet, so I cannot answer the question. Would be good to try out though. I could imagine that it doesn't work right now, but it should be a quick win, I guess, for the model providers. Yes.
Thanks for the great talk. Can you actually dig in or monitor what happens in the single steps, like when you show it in the local setup, what happens in the text-to-speech part, and see where the error happened?
Yep. Question is if we can trace basically the conversation. You could. Usually you would not basically do setup directly locally, but you would have a server in between that basically just relays the communication, and that could trace what's happening between the browser and the AI model then. So yes, that would be possible and should also be done from my point of view if you want to evaluate if that thing does what it should do. Yes.
I wonder how authentication works, because I guess you pass in some kind of API key.
Mm-hmm.
And I'm wondering if you're doing the connection peer-to-peer from the front end to OpenAI. I'm wondering how that works, because I'm just publishing it.
Mm-hmm. Good question. So authentication was the question. How does it currently work? The idea is that you would not indeed connect it directly. So here in the demo, there is a key exchange happening, or token exchange happening. So basically, the server knows your exact API key, and it can trade it into an ephemeral token, and that is basically handed over to the browser, to the client. The token is valid for 5 minutes or something like that, and then basically it can acquire a new one so that you don't have to put the key into your application, which would be pretty bad, of course. Also, like the entire authentication for the agentic workflows, that's something that is currently being discussed. So basically what happens if you say, please look up my GitHub repositories. So where does the key come from? And that is something that is currently being discussed. Many also competing proposals on how to solve this. It's going to be interesting. It's not solved right now. All right. So I guess that's it. If you want to see more about AI, we also do like local AI. That was basically the content of our workshop yesterday. So if you missed that, you may want to join for the next session. Same room, same speaker. Yeah, hope to see you there. Otherwise, have a great rest of the day, and yeah, see you soon.